Hello kids, here is a shout out to my most very favorite students from Miss Fliegel-Schnoitz's Algebra 2 class, to Bree and to Cassie and to Rachel and to Laura. My life is the richer for knowing you. And now you get to listen to two exceedingly lame jokes from the book. Why did the bones chase the skull? Because they wanted to get ahead. And why do rabbits hate Elmer Fudd? Because he bugs bunnies. So what we're going to do on this video right now is we're going to talk about linear relations. This is section 3.1 in our Algebra 2 book. I left my text at home inadvertently, so I'm going to use Rachel's right here. This is just a quick review of things that we've already done in Algebra 1. So by a quick review, what I mean is they've taken material that was perhaps as much as 4 sections, lumped it all together just to refresh you where we are. Now, a relation is a way that you can lump two different pieces, two different sets of information together. And you can describe relations using a graph. You can describe it using set notation. You can describe it using ordered pairs. But before you can do a graph, you have to be able to understand what the Cartesian coordinate system is. So this is a graph of the Cartesian plane. Cartesian plane. And a Cartesian coordinate system consists of an x-axis crossed with a y-axis. The x-axis is horizontal, and the y-axis is vertical. So what we have here are 2 dimensions. And the way that this graphing system is set up is very similar to how we would play Battleship. Except when we played the game Battleship, we were only using one of these 4 sections. 1, 2, 3, 4 sections here. These are called quadrants. This one here is quadrant 1. Q1, this is quadrant 2, Q2, quadrant 3, and finally quadrant 4. So we're starting, so we're starting in the upper right-hand corner, and we are going in reverse clockwise direction. We're going in counterclockwise direction. We have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. On our horizontal line that we have here, which is called the x-axis, we have our positive numbers to the right, and we are going negative numbers to the left, just as if we were simply drawing a number line. This point where the x-axis intersects with the y-axis right here, that little point is called the origin, and it has the coordinates 0, 0, origin. Our y-axis, we're going to put the markings on that, positive, negative, just as you would a thermometer. Positive values go to the top of the x-coordinate. Negative values are to the bottom of the x-coordinate. So we have quadrant 1, 2, 3, and 4. We have all positives. Have different relationship between our ordered pairs. In quadrant 1, this would be what we're most accustomed to thinking of, whether we're working with reading one of those old-fashioned paper maps or whether we're playing Battleship. If we said, okay, I want you to go 2 units on the x direction and then 3 units up, and this would be represented by the ordered pair 2, 3, what this ordered pair says is go 2 units in the positive direction on the x-axis, go 3 units in the positive direction on the y-axis, and that lets us know exactly where this point is. And this is the principle that a GPS system works on now. They map latitude and longitude by bouncing things off satellite, and rather than have some real rudimentary graphing or rudimentary mapping like you would in an old paper map. They can identify an exact location based on latitude and longitude. But anyway, the identification of this point is identified by the ordered pair 2, 3, which means the x value is positive 2, the x value is positive 2, y value is positive 3. Now what I'm going to do is make a box here, sort of, if you are really trying to figure out how to get my thing to stick here. It's not doing a very good job. Didn't remember to bring my own eraser. So we have this coordinate point that I'm going to graph here, we have this point, and then we're going to have this other point over here. I also don't like having different colored markers, but I guess we'll live with it. Okay, so this is quadrant 4, and this over here, of course, is quadrant 3. And we do use Roman numerals to identify those. If in this ordered pair here, the first number is the value on our x-coordinate, it's going to be a -2. You go over -2 points, and then you go up 3 points on the y-axis. Same thing here, our x value is -2, our y value is -3. X value is positive 2, y value is -3. And I want you to see the relationship between the positive and negative values. In the first quadrant, both the x value and the y value are positive. In the third quadrant, both the x value and the y value are negative. In the second quadrant, we have negative, positive. What do you think we're going to have in the fourth quadrant? Right, it reverses again. You have positive, negative. So all of this very busy board right here, all this is doing is reminding you of what a Cartesian coordinate system looks like. It's named for René Descartes, who was a famous French mathematician several hundred years ago. We have the x values, which is the horizontal axis. We have the y-axis, which is vertical. I'm thinking we have ordinate and abscissa. I think it's abscissa and ordinate that are the words that we use to describe the x and y values, but since they don't mention this in your book, we're not going to worry about that. Ordered pair identifies a location in the plane. So what this says is that just like with our physical address that we have for our houses, that locates one specific unique place on the whole globe. You know, first you might break it down by country, then by city, then by location with country or state or province or whatever, then an actual city or village, then an actual street, then a specific house or an apartment, and then a specific apartment room in that apartment building, so it identifies one unique place in the globe. So with the ordered pairs, x and y, it identifies one particular place in all of the infiniteness of a plane, because remember, a plane is like a sheet of paper that goes on forever in all directions. When we have 3 dimensions, they have that third axis that comes out to give us 3 dimensions. It's the z-axis, but you won't worry about that until you're in calculus. So here's a review of the Cartesian coordinate system. So you can use set notation, you can use the idea of functions, which is domain and range, or you can use a grouping of ordered pairs to identify a relation. So let's look at this little bit of information here. Now I'm not even going to do example number 1, but if you're told to graph these points, 2, -3, 4, 7, and 3, -6, on a Cartesian coordinate, they're not going to say graph it on a Cartesian coordinate system. They're going to say graph it. Well, you've got your Cartesian coordinate system that you are using a ruler to draw nice straight lines, and you go 1, 2, 1, 2, 3. So this is a point -2, 3, and the point 4, 7. And you can see that I'm obviously, let's see. Okay, that's a 2, -3. And this here is a 3, -6. Maybe this one right here is 3, -6. All you have to do when it says graph an ordered pair, the first value is the x, the second value is the location on the y-coordinate, and you identify those on a Cartesian coordinate system. That's all they want you to do. Now let's say that if we're going backward, and we have a picture, and you have a picture here. And it says, give the relations that are shown by this. So let me do 2. I'm just trying to sketch really fast. That one, and that one, and that one. And your instructions say, give the relation shown by the graph. So here they want you to use what they call Setbuilder notation. So this would be the set. Those braces can be read the set. So here we have that this would be the set containing 3 different ordered pairs because we have 3 points, right? And a point on a plane can be identified with an ordered pair. So let's see what 3 ordered pairs we have. Well, first, remember your first value is going to be x. Your last value is going to be y. So we have 2 in the left direction, so that's a -2, and we've gone down to -2. That identifies this point. What about here? X is 1, y is 1. Hey, looks like a silly face, doesn't it? Over here you go 2 units in the x direction, but you make no change at all in the y direction. So when it says give the relations shown by this graph, what you do is you go in and you figure out what those coordinates are, and then you use this Setbuilder notation to show the points that are a part of that relation. So this is a relation here. We're graphing the relation of ordered pairs. So your book says on page 88 that a relation is a set of ordered pairs. And all ordered pairs is groupings of pairs of items where there's a specific relationship between them, like maybe a price of 75 cents is the price of a candy bar or a pack of gum if you're fortunate. Or maybe a number 7 is associated with pencils, and a number 12 is associated with pens, and a number 3 is associated with erasers. That's all that relations are. And another way that you can illustrate a relation, besides graphing and besides using Setbuilder notation, is by using what they call a mapping diagram or a circle map. And circle should give you a good idea here that you're going to have circles. So you have one circle and you have another circle. The first circle identifies the elements that are in the domain, and the second circle identifies those elements that you're going to find in the range. So this says draw circle mappings for the relations in example 2. So let me go back over here and use this exact thing. Okay, we had set A consisted of the ordered pairs 1, 3, 3, -1. I'm going to have to go to the librarian and get a better eraser. 3, -1, 3, 2, and 5, 4. And then you have set B, which has only two ordered pairs in it, and they are the ordered pairs 2, 1 and 3, 1. Okay? It says use circle mappings or circle graphs to show these. So what the domain is, that's all the x values. All possible x values. Boy, I wish I had different colors. All possible x values. And the range is all possible y values. So if this is set A, what possible x values do we have here? Well, x is 1, 3, and 5. And even though 3 is used 2 separate times, we're only going to write it down once in our circle map. And then what do we have here? We have 3, -1, 2, and 4. So I'm going to want those to be in numerical order, lowest at the top. -1, 1, 2, and 4. And now we're just going to make an arrow that matches up our domain value 1 with our range value. Remember, the first circle on the left is all of the elements in the domain, all of the possible x values. Our second circle is all of the elements in the range, which is all of our possible y values, 3, -1, 2, and 4. So what goes with 1? Well, 1, what did I do wrong? -1, okay, I said 1. It should be -1, 2, 3, and 4. -1, 2, 3, 4. Sorry about that, guys. 1 maps to 3, so you draw the arrow like this. 3 maps to -1. 3 also maps to 2. And 5 maps to 4. So this is showing you the relationship between these. 1 goes to 3, 3 goes to -1 and a 2, and 5 goes to 4. If you look in your book, you see that they didn't put the y values in numerical order. Doesn't really matter. I learned to do it this way. As long as you have your arrows connecting correctly, you'll be fine. So, what would if this is our set A, what would set B look like? Well, sure. Set B is equally simple to draw. So I should have just probably been further and faster ahead to have erased it. What values are in our domain? What x values do we have? We have a 2 and we have a 3. What do we have for a range, or what y values do we have? We only have 1. So the 2 maps to 1 and the 3 maps to 1. And that's all that we have going on here. So you should be able to express a relation in 3 different ways. A relation can be expressed using a circle graph. This circle graph right here is expressing this relation that's also expressed using set notation here. 2 and 1 pair together, 3 and 1 pair together. This says 2 and 1, 3 and 1. You could also have the graph that shows this relationship, where we have x is 2 and x is 3 and y is 1, 2 is 1, 2 and 1, and 3 and 1. 3 different ways to illustrate the relationship between these numbers on a plane. Our x values are 2 and 3, our y value is 1. Our x values are 2 and 3, the y value is 1. The x values are 2 and 3, the y value is 1. Or another way of looking at it is that our values for our domain are 2 and 3. The values in our range are 1. We can use a circle map, we can use Setbuilder notation, or we can use a graph on the Cartesian coordinate system to show those relations. And that's all that there really is to section 3.1.